Okay, now we are ready for question number 9. The equation that they give us has a y for years in the exponent up here, but in the question we want to know how we would calculate with months. Well, if I told you how many months we had, you would have to convert that into years by dividing by 12. For example, if I said that our months number was 12 months, well, that makes a year. So you would plug a 1 in for the exponent of y. If I said our month number was 24, well, that would be 2 years. If you take 24 and divide it by 12, you get 2. So you would plug a 2 into our exponent of y. So whatever I say for the number of months, you would have to divide by 12. So I could rewrite this equation as 20,000 times 1.08, and then I would take my months and divide it by 12 to replace my year's value. Well, if I think about this in pieces, let me take this months over 12 and rewrite it as 1/12 times m. That would be equivalent. Then if I do some regrouping right here, inside our blue parentheses, you have all numbers. That means you can calculate that value. So take your calculator, take 1.08 to the 1/12th power, and you will get option D. On number 10, we are converting from exponential to logarithmic form. So when you do that, the base in this is a 3. So the base goes down here. The argument is a 30. Remember, that's the answer that you come out to. And when you take a log, what you get is the exponent. And in this case, that is an x. So log base 3 of 30 matches A. In question number 11 here, we're converting from logarithmic to exponential form. So first of all, we have a 2 out front. So if we are multiplying by 2, when you are multiplying exponents, that means you must have a power to a power. So I'm going to take that 2 and return it to its rightful position as an exponent. So it would be x squared. And then I'm going to bring the equals -1 over. So now let's rewrite it. Our base is a 9. The exponent would be the -1. And the argument is x squared. So that matches A. Question number 12 is also converting the form. So we have a log. We're going to take a log. The base is the 1/4. The argument is the 64. And that tells us the exponent, which in this case is a -3. So that matches D. On number 13, let's see. Okay, so on this one, you want to find when it increases by 10%. If you analyze what the base on the exponent is in here, do you see the 1.1? Well, that means you must have a rate of 10% because you would have a 1 plus r to the t power here. And the 0.8 is our initial value, so I could call that A. So to tell when this is going to increase by 10%, we would want to know when this exponent is a 1. Well, we have a little bit more complicated exponent here. We have a 0.2 times t. Well, if I plug a 5 in for that t, a 0.2 times 5 would come out to equal 1. So we want a 5-year period here.